Hello students, hope you are keeping well and doing your work. So students, on the last turn we completed with Newton's first law. And what was it? It was every body continues to be in the state of rest or of uniform motion unless and until an external force is applied on the body. So now we are going to study Newton's second law. Now, before studying Newton's second law, I want you people to know that suppose if you have a body of 100 kg mass and you have a body of 1000 kg mass. Students, which body is easier to displace? I think your answer is 100 kg mass. Yes, that's correct. It is easier to displace 100 kg mass as compared to 1000 kg mass. So, from here I may conclude that force is directly proportional to the mass of the body. So, larger is the mass, more force applied to displace the body. And smaller is the mass, less force applied to displace a body. I think you know the meaning of directly proportional. When one quantity rises, the other also rises. And when the other quantity lowers down, the first also lowers down. So that is the meaning of directly proportional. So from this example, we concluded that force is directly proportional to mass of the body. Another thing which comes into the scene is, suppose a car is moving with a speed of 20 meters per second and another car is moving with a speed of 100 meters per second. So, which car will be easier to stop? I think your answer will be the car moving with the speed 20 meters per second. Yes, you are correct. The car which is moving with less velocity will be easier to stop as compared to the car which is moving with a greater velocity. Now we will study these two things in the later one. Let's move further. So we studied about that if we have a greater mass, we have to apply more force, and if we have a smaller mass, we have to apply less force, and therefore force is directly proportional to mass. We also studied that velocity is also directly proportional to force. That means greater the velocity, we have to apply a bigger force, and smaller the velocity, we have to apply less force. Okay. Now, as you can see in the figures here, the man is pulling and he has to apply more force to pull up, displace 400 kgs mass. And below figure, you can see that a light ball, when the person has thrown the ball with the bat, then it goes a longer distance with a greater speed. Whereas a heavy ball, when given the same force, drops there only and with a slower speed, and therefore it depends upon the force as the velocity increases or the mass increases, the force has to increase. So from this figure you are clear with this, that force is directly proportional to mass as well as velocity. More the mass, more the force, more the velocity, more the force. Okay, so we move further. Now students, from these two things, we come to a conclusion, and that conclusion is in the words of momentum. Now what is momentum? We are going to study. Momentum is the product of mass and velocity. Momentum equals to mass multiplied by velocity of the body. Momentum is written with small p. Momentum anywhere, if you see small p in physics, that means momentum. Momentum is equal to mass multiplied by velocity. Now, as we mentioned that force is directly proportional to mass as well as velocity. Now, Newton's second law will be defined in the terms of momentum. That is why we are studying momentum here. This had to be introduced. So, the rate of change of momentum is directly proportional to the force applied. Okay, so rate of change of momentum is what? Product of mass and velocity is directly proportional to force. Okay. Now, as it is written here, moving objects exert a force on anything which it tries to stop it. So, if something is moving, that will exert a force on anything which is trying to stop it. A moving car will exert a force on you if you are trying to stop the car. Okay. Faster the object is traveling, harder it is to stop. You have to apply more force. And if two objects having same velocity, then it is more difficult to stop the massive one. That means having the more mass. Okay. So all these two things have been clubbed, and this quality of the moving body was called the quality of motion of the body, and now it is called as linear momentum. Momentum in a straight line is linear momentum. And what is linear momentum? I mentioned P is equal to mass multiplied by velocity. That means the product of mass and velocity is linear momentum. Okay, so we move further. Now, as I mentioned, how is momentum and Newton's second law connected? The definition is rate of change of momentum is directly proportional to force applied. We'll learn the definition later, but first we will understand how. So, from this momentum, we can come to the second law of motion. From here only it has been derived. So we are going to study that. Okay. Now how? We said that force is directly proportional to mass and velocity. So if I club mass and velocity together, that means if I multiply mass and velocity, so yes, force is directly proportional to the product of mass and velocity. Now, force is directly proportional to rate of change in momentum. Okay, so final momentum minus initial momentum, that is rate of change of momentum divided by time. In a given time span, whatever is the change in momentum, that is directly proportional to force. Yes? You know the meaning of directly proportional now, so that I have written it in the corner. So force is directly proportional to rate of change of momentum. Therefore, force is directly proportional to change in momentum upon time. Rate means anything which is having time in configuration. So, change in momentum upon time is known as rate of change of momentum, and that is directly proportional to force. Now, from here we get Force is directly proportional to final momentum minus initial momentum. That is change in momentum. Whatever is the final momentum minus the initial momentum upon the time interval is directly proportional to force. So force is directly proportional to mv. Final velocity we will take v and initial velocity we will take u. Mass remains the same, students, isn't it? Mass will not change. A body which is having a particular body which is having some mass, that will remain same. So mass will be m in the first case also and m in the second case also. So there is no change in the mass of the body, only the velocity will change. Okay, so force is directly proportional to mass into final velocity minus mass into initial velocity upon time interval. So force is directly proportional to mass multiplied by v minus u by t. If you take m common from the above equation, you get m common v minus u and then in the denominator t. Now if you remember, v minus u by t is what? Acceleration. So force is directly proportional to mass multiplied by acceleration of the body. Okay. Now we have an alternative method of this also. So first we'll study that also. So we move further. Okay, students. So I mentioned that momentum is denoted by small p. Now, as we learned earlier in the earlier slide, that force is directly proportional to rate of change of momentum. Now, rate of change of momentum, what is it? Change in momentum upon time interval. Now, this triangle which you can see here is the Greek word known as delta. This is a Greek letter known as delta. And what is delta? Delta means change. So change in P upon T is directly proportional to F. Here we have written equal to because we are taking the proportionality constant as 1. Okay, we will study about proportionality constant in the next slide, but here we have taken F equal to delta P by T because we have assumed that the proportionality constant that was directly proportional, so the proportionality constant becomes 1 in this case. Okay, so F is equal to change in momentum upon time interval. Now F is equal to delta, instead of P we can write mv, so delta mv by T. Now as I mentioned in the earlier slide, mass will not change, students. Mass remains the same, only the velocity changes. There are some exceptions where the mass changes, where the speed of the object is too high, that it is in comparison to the speed of light. Practically nothing can move faster than light, but some objects like electrons, atoms, very tiny masses, if moved with a comparable speed as the speed of light, then their masses change. We will not go into the detail of that. Practically or ideally, the mass of the object does not change. Okay? It is only the velocity which changes. Therefore, mass has been taken out from the change. It is only delta V. Delta V means there is only change in the velocity and not in the mass. So F equals to mass then multiplied by delta V by T. Okay, t remains the same in all, so that is a time interval. It is only the change in the velocity, that is v minus u here. So f is equal to m delta v by t, and what is delta v by t? V minus u by t, and that is acceleration. So change in velocity upon time interval is acceleration. So from here we again get f is equal to ma. In the last slide also we got f is equal to ma. Okay, now we are going to study about the proportionality constant. So we move further. Now, as I mentioned, from the second last slide which we did right now, the rate of change in momentum is m multiplied by v minus u by t. And from the last slide which we did right now, m delta v by t. And from both these, we were getting f is directly proportional to ma. Okay. Now, according to Newton's second law, f is directly proportional to mv minus u by t. Now, you know this. Now, this proportionality sign can be changed to equal sign by taking a proportionality constant, which is k over here. So that directly proportional sign has been changed to equal to sign by multiplying with k. So f is equal to km v minus u by t. Now, k is the proportionality constant over here. So we say f is equal to k m a. V minus u by t is a. So we say f is equal to k m a, where a is v minus u by t. That is the rate of change in velocity. That is acceleration, and k is the constant of proportionality. Now let us find the value of k. Putting m equal to 1 kg, acceleration is equal to 1 meter per second square, f becomes 1 newton. So 1 newton is equal to k into 1 kg into 1 meter per second square. So k comes 1 over here. So in all the cases where we are applying the Newton's second law, we take the proportionality constant k as 1. Okay. Now from here we derive that Newton's second law is equal to f is equal to ma, where the proportionality constant k is 1. Now the unit of f will be, now you know it is mass, so SI unit of mass is kg, and for acceleration it is meter per second square, so it is kg meter per second square, which we write as Newton. So the SI unit for force is Newton. And what is the CGS unit? CGS unit is, for mass it will be grams, and for acceleration it will be meter per second, centimeter per second square, and therefore it will be gram centimeter per second square. Okay, so we will move to the units in the next one. So let's move further. So now, after understanding all this, you will understand this in a better way. Now, this is the definition for Newton's second law. The rate of change of momentum of a body is directly proportional to the force applied on it. Yeah, is it clear? Now, rate of change of momentum of a body is directly proportional to force applied on it in the direction of force. So formula is F is equal to ma, SI unit as I mentioned, kg meter per second square or Newton, and CGS unit gram centimeter per second square or dyne. Now what is the relation between Newton and dyne? We are going to see 1 Newton is equal to 1 kg into 1 meter per second square, we know. Now 1 kg when changed to grams, that will be 1000 grams, and 1 meter when changed to centimeter, that will be 100. And when we multiply all this, that is 1000 into 100, that is 10 to the power 5 gram centimeter per second square. And what is gram centimeter per second square? Dyne. Okay. So 1 Newton is equal to 10 to the power 5 dyne. Okay. So let's move further. Now this is to obtain Newton's first law from second law. Now to get Newton's first law from F equals to ma. How? Now if we put F equal to 0. Now if F is 0, then what is 0? Either the mass is 0 or the acceleration is 0 or both are 0. Now you know mass cannot be 0. I have made it very clear that mass of a body cannot be zero. Okay. So then what is zero? Acceleration is zero. So if F is zero, A is zero. That means if no force is applied, there is no acceleration in the body. And what is acceleration? Change in velocity. That means there is no change in velocity of the body in a given interval if there is no force applied. That means what? A body continues to be in the state of rest, and a body continues to be in the state of motion unless and until an external force is applied to it. I think the things will be clear to you now. Okay? So let's move further. Now, this is mathematical expression of Newton's second law. How do we take this formula in our daily life examples? Okay. Now, force is equal to what? Rate of change of momentum. So that means F is equal to delta P by delta T. Therefore, delta P can be written as F into delta T, isn't it? Now, change in P is equal to F into delta T. F is the same. The force is the same. Change in P is equal to F into change in T. That means the time interval. Okay. Now, so a given change in momentum can be brought about either by applying a small force for a longer duration if there is a change in momentum. Suppose the momentum has increased. So if the momentum is increasing, the right side will also increase. That is F into delta T will also increase. Now, to have this increase, what will happen? Either you have small force for a long duration, or you have a greater force for a small duration. Okay. So for a given change in momentum, if there is increase, then also, if there is decrease, then also. So for a given change in momentum can be brought about either by applying small force for a long time or applying large force for a small time. Example, hammering a nail. When you're hammering a nail, then what are you doing? You're putting in more force for a small time interval. And that is why it is being hammered. If you will do like this slowly, the nail will not go anywhere. Okay. Therefore, a large force for a small time is hammering the nail. Whereas when you're catching the ball, when the fielder is on the ground and is about to catch a ball, what does he do? He brings his hands backward while catching the ball. Okay. Why? Because the ball is coming with a very large force, and just to decrease the amount of force, he is increasing the time span. And therefore, it is for the given change in momentum, he has increased the time interval to have a lesser effect of that great force. Okay. I think the Newton's second law is clear to you people, students. If still you have any problem, you may ask me in the comments below. And next turn, I'll be doing some questions and I'll move to Newton's third law. So till then, take care. Bye-bye. Have a good day. Thank you.